Page 231. So we're going to start evaluating logs, like actually figuring out what the value of a log expression is. We will learn that today. But first, we're going to do it without the log button. I know. Okay, so log base 3 of 81. I want to evaluate it. So basically what you're doing now, I'm going to start slow. When you get good, you will not do it this way. Okay, but this is the introduction. So I want to figure out what this number is. So I go, okay, it equals some number x. And then you change to exponential form. How do you change this to exponential form? The 3 comes over, kicks up the x, and you get 81 is equal to 3 to the x. And then, like we did lesson number 2, and you just did in the assignment, you make them the same base. 3 to what power is 81? 4. So what does x equal? There you go. Which means log base 3 of 81 is equal to 4. Okay. Now, like I said before, this is the long way. When you get good, we have to learn a couple things first. But in about 20 minutes, you will not do it this way, hopefully. Okay. Some of you might, but hopefully we don't. All right, let's do the next one. Log base 4 of 64 equals some number. What do I do? Doesn't equal 4. Oh, 64. Are you saying this? 64 is equal to 4 to the power of x. 4 to what power is 64? 3. So therefore, x is equal to 3. So that whole thing equals 3. I want to do these last two here. C, log base 7 of 7. Don't listen to Noah. 7 is equal to 7 to the x. What does x equal? 1, right? Because that's a 1 right there. They're already in the same base. One is equal to 12 to the x. The only thing that can make that true is x equals 0. Is that okay? All we're doing is changing to exponential and then making a common base. That's it. We're okay with that? All right. Log base b of 1 equals what? What is its value? What do I do? One is equal to b to the x. What's x equal? Okay, what can you conclude about logging the number 1? Yes. It doesn't matter what the base is. If you log the number 1, it always equals 0. You need to remember that. Okay? It always, always, always equals 0. Doesn't matter what the base is. I'm not going to do this one. Let's do... Okay. Let's do A here. Evaluate this. So we got 2 log 8 of 512. Ignore the 2 for now. Just kind of put it off to the side. Just deal with the log 8 of 512. We have to evaluate that. Sorry? Yeah, but it's not an equation. So we can't divide it off. So we're just trying to figure out what this value is. So I'm going to say, okay, that equals some number. We're going to change to exponential. What do I do at this point? Yes. 512, you make them a common base. Therefore, I get x is equal to 3, which means this whole thing equals 3. But what number is in front of it? 2. So it's 2 times 3 equals 6. That's the value of 2 log 8 of 512. Okay? Okay. I'm going to save the next two because it's kind of a pain in the butt to do this all the time. So we're going to go down to the bottom here. We're going to do these ones, and you're going to come up with a formula for me. So we have 5 to the power of log base 5 of 25. So our exponent is a log, which looks super ugly and crazy. Okay? But we're going to just deal with the exponent. Okay? I'm just going to go log 5 of 25. What does that equal? So you're going to change the exponential. So what does x equal here? Has to be 2, right? Does everybody agree with that? So I get x equals 2. That's the exponent, right? So now I'm left with 5 to the power of 2, which is what? 25. So what that means is 25, the value of 5 to the log base 5 of 25. Okay. Let's do the next one. Again, it's the exponent. So just deal with the exponent by itself. Equals x. Change to exponential. So x is equal to 2. So then I get 7 to the exponent, which is 2, which is 49, which is equal to the actual equation, log 7 of 49. Is anybody seeing a pattern here? We've only done 2, so what's the pattern? If I give you this, 5 to the power of log base 5 of 25, we just found that it equals 25. 7 to the power of log base 7 of 49 equals 49. What does this one equal?
27.
27. If these bases match, this and the base on the log match, it's whatever the argument is, whatever number you're logging. Okay? So this one is just 27. And that's an actual rule. So, for example, if I go, like I give you this, whoops, a to log base a of n, without doing any work, you would tell me the answer is n. Know that. It will make your life so much easier. Not that, know this. Okay, now, what about this thing here? Log base a of a to the n. I'm going to evaluate that. So I go, okay, that equals x, some value. What do I do? Change to exponential. So if you change to exponential, you'll get a to the n is equal to a to the x. What does x equal? N. Therefore, log base a of a to the n always equals n. Whatever the exponent is on the argument. Okay? So these two things are important. Because if you know these two, you don't have to do all this stuff. Okay? You can just put the number because these are identities. We've just shown that they're identities, all right? So if I gave you, let's gonna make up a couple examples here. So if I said log base 4 of 4 to the third, you would tell me the answer is? Exactly. Now, what if I do this? Log base 4 of 16. It's 2. Why is it 2? Because I can rewrite the 16 as 4 squared. Then this matches this. Therefore, I know the answer is just 2. Okay? So this saves you having to do a whole bunch of work. However, you got to be pretty good at mental math. Okay? So if we scroll back up here and we look at this one right here, one we did at the beginning. 2 times log base 8 of 512. Ignore the 2 in the front. 512, can that be made into base 3? Or base 8, sorry. Yes, it's the same as this. Of 8 cubed, right? 8 cubed is 512. So that means this whole thing, this whole thing is equal to 3. The 2's out in front, so I know my answer is 6. So you don't have to do this. Yeah, and you can do them quickly. Okay? So, B, 2, log base 2 of 1 over 32. When you get a question like this, ask yourself, can this argument be made into base 2? Yeah. It can. First of all, what do you got to do? It's a fraction. We don't want a fraction because this isn't a fraction. So you flip it. Now I'm going to show all the steps. You can do them in your head or you can write them in one step. So I'm going to go log 2 of 32 to the negative 1. That's the same thing, right? Okay. What 2 to what power is 32? Is that the same thing? So what's my answer? Negative 5. Okay. Now, obviously, you don't have to show those steps. If you can do them in your head quickly, just give me negative 5. All right? Now, C, log base 5 of square root of 125. We don't want a square root. I don't want, when you have logs, you don't want radicals. You want exponents. So how do I rewrite the radical as an exponent? 125 to the power of 1/2. And then you ask yourself, can 125 be made base 5? What is it? 5 cubed. So what's my answer? 3 over 2. It's that, right? Because you're multiplying those exponents. So it's 3 over 2. All right, we're going to do a couple more. So I'm going to need you to skip to page something. This page, 236. Page 236. We're just going to do these ones. All right. Negative log base 7 of 1 over 343. So ask yourself, can 1 over 343 be made into base 7? So first of all, you have to flip the fraction. And 7 to what power is 343? It's 3. So it's 7 to the negative 3. What's my answer? Positive 3 because you have a negative in front. That becomes negative 3. So you just get 3. B, you don't even have to do anything. What is the answer? 216, because this base and this base match. Done. Wouldn't. C, what do you have to do? So you're going to flip it, and you got to make the radical an exponent. So I'll do it in a couple steps. So I'm going to get 1024 to the negative a half. 2 to what power is 1024? Anybody know? Is it 10?
Yeah, it is 10.
Oh, okay.
Wow, Mr. Baldwin.
2 to the 10, and it's a negative a half. So what's my answer? Boom, negative 5. What? Because the negative a half is this, right? And then I multiply these two exponents. 10 times negative a half is negative 5. Ah. And then final one, what do I need to do to D? What do I have to change? The 49 to what power? 7 squared, right? So what's my answer? Negative 10. When you get good at this, you will do these quickly in your head without even writing anything down. Okay? And that will make your life easier, especially when you have big, long problems. You can simplify things very quickly and then just focus on the algebra you need to do. Okay. I need you to do questions. Number 1. Number 2. Yeah, you can do 3. And what was the other one that I wanted you to do? 8, I guess, but that's pretty easy.
I guess.
If you want a challenge, 13. There you go. So what did I say? 1, 2, 3, 8, and 13. Please. Okay. So, log 5 of 50. If I asked you to solve this, you would say no. So you would go, oh, okay, I do this. I get 5 to the x. Can 50 be made into base 5? No. So we run into a problem. Our techniques don't work. Okay? So what we can do is we can use our calculators. All right? So there's 2 types of common logs, I guess we would call them. All right? The first one is base 10. All right? Base 10 is so common, they don't even write the 10. All right? If they just write the word log like this, that means base 10. So on your calculator, you should have an LOG button. Does everybody have an LOG button?
Yeah.
So when it's base 10, that is the button you hit. So if I asked you to evaluate log base 10 of 89, you would tell me the answer is 1.9495, whatever. Did you figure it out, Peyton? Oh, Peyton.
You don't need the base, bro.
See what log 2000 is.
Log 89? Oh, because 10 is automatically the base. Okay, what if I need a base? I don't. He's probably gonna teach us this. What? People with faces. That's what it's a I hate that. He went back in his lips. I need some. You can have mine. Just use this one. I can use this one. This one's special. I just use this one on in someone's house that I'm like using this later. Just kidding.
What's log of 2,000? 3.3, I don't know, 0, 1, 0, blah, whatever. Who cares? All right. So if if no base is written, they mean base 10. Okay? So that's the LOG button on your calculator. Now, if you go to the next page, there is another common base that is called the natural log. And it is base E. Okay. Does anybody know what E is? E is like pi. E is a number, and it's 2.718, blah, 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 goes on forever. That is base E. The natural log, or base E, shows up in weird places. It shows up in finance a lot and all these different formulas, okay? So another common log that you will see is the natural log. Now, that's abbreviated. Nobody writes log base E. They don't write this. They write ln. Okay? ln is the natural log. Okay? So you should have an ln key. Everybody calls it in because it looks like the in, but it's actually ln on your calculator. You should have an ln button like this. Did everybody find that?
I did.
So if they ask for the natural log of 5, you would tell me the answer is 1.609. Please make sure you can get that. What's the natural log of E? It should be 1. Why should it be 1? Okay, what does the natural log mean? It means log base E of E. If the bases match, it's always... Yeah, it's not in. It should just give you 1.
I got it. It's error 1.
Error 1? You're not doing it right. Okay.
Yeah, I got syntax there.
Did you really?
I didn't see the right there.
Yeah.
Wow. Whoa.
All right. Okay. Are we good with that? Does everybody understand the difference between log base 10 and natural log? Yeah?
Yeah.
Okay. We're not going to approximate the value of that. All right. Here is your first identity. So, some calculators, such as okay, some calculators such as this one, Casio FX300 ES Plus, will allow you to change to any base you want. Other calculators such as this one will not. These calculators will only do, hang on, will only do base 10 and natural log. Okay? So, you need to know how to change the base. And this is the change of base formula. It looks complicated. It is not. Okay? So, I will give you this formula. All right? You don't have to memorize it. You just have to know how to use it. So this is what it does. Log base B of C. You can change to any base you want. And don't think that your calculator will always solve everything for you, because I'm going to give you questions with variables as bases and you can't punch those into a calculator. Okay? So you have to know how to do things. So, when you're changing the base, the argument of the original goes into the numerator log, and the base of the original becomes the argument of the denominator. Now, A, the base that you're changing to, this thing, can be whatever you want. So, for example, if I have log base 5 of, 6, and I want to change it to base 10, I'm going to write log, and now I'm going to write the 10, even though you don't have to write the 10. Log base 10 of, the argument goes into the numerator, divided by log base 10 of what? 5. Okay, that's the change of base rule. And then this, you can punch into a calculator. All right? Because this one you can't unless you want to have one of those smart, fancy calculators over there. All right? So if we go down here, we'll do log base 5 of 221. You cannot punch that in your calculator. Some of you can't punch that in your calculator. All right? Because it's base 5. So we need to change the base. It doesn't matter what base you change it to. You can pick any base you want. What would be the two smartest bases to use? 10 or natural log. It doesn't matter which one you use. So if I'm going to change it to the natural log, I can go ln of 221 divided by ln of 5. Please do that on your calculator. Smart people or smart calculators, try the log 521, and then everybody else tell me what. We'll see if we get the same answer. $3.35, is that what people got? Yeah?
This is what it is. Oh, it's 221. Crazy.
All right. Are we okay?
Yeah.
What if I had changed it to this? Log 221 over log 5, base 10. Do I get the same answer?
Yeah, true.
Check it. Don't just take my word for it. What?
It's the same. It's the same.
It's the same. I know it's the same.
So,
It doesn't matter what base you choose, okay? You can choose any base you want. So what if you have a number in front, a 3 like this? What do I need to do? Yeah, so just forget about it. Do this thing. So log 512 over log 7. Figure out what that is. Multiply it by 3, and the answer is... No, you got your fancy calculator. Not for these ones.
How many sig figs do we have to put?
78.
What?
78 sig figs, please. 78 sig figs.
Mr. Baldwin, can you please explain the rules for that?
There is no rule. I'm just making it up. It's a Baldwin rule. 78 sig figs on every question.
Oh, that's too
There's only 2 questions on the test, though. So. But if you get 1 sig fig wrong, whole question's wrong.
What if it goes to a straight zero? Do I have to write 78 zeros, or can I put like point to the?
Oh, I need to see all the zeros.
You need to see all.
I need to see all the zeros. Okay, is that okay? Here's what you're doing: 5, 6, 7,
We're doing 9,
11.
9.
Do you want to do 9?
No, 5. No, we're good. We're good. 7. No, I just missed it. I just said wrong.
Yeah, there you go. 5, 6, 7, 11, please. That'll take us up to the end of class.